All right. Next up, we're going to take a look at cube roots. Again, we'll review our curricular outcome, some prerequisite knowledge review, and then we'll dive into the new content. So our curricular outcome, our learning goal, is to demonstrate an understanding of factors of whole numbers by determining the cube root. So, quick prerequisite review. So, to algebraically find a square root, you look for multiples of 2 in the exponents of your prime factorization. Now, when we cube n, we calculate n cubed. Named because ancient Greeks treated this process as turning a line of length n into a cube of volume n cubed, much like the square was line of length n into a square of area n squared. So finding cube roots. In a square root, we looked for multiples of 2 in the exponents of our prime factorization. In a cube root, we're going to be looking for multiples of 3 instead. And we don't divide them by 2 when we pull them out of the radical, we divide them by 3. Notice now we have this index of 3 in our radicals. So we have that little 3 tucked in there. Anytime it's not a square root, we will have that mark pointing to it for us. So our cube root of 128, well, that is 2 exponents 7. So the highest multiple of 3 that is less than or equal to 7 is 6. We pull our 2 to the 6 out, but divide the 6 by 3, we get 2 squared. So 2 squared times the cube root of 2 is 4 cube root 2. That is our cube root of 128. In general, if you have the nth root of x exponent n, you just get x. Square root of x squared, cube root of x cubed, fifth root of x to the 5th. That's just going to get you your x back. Now, negative numbers always have real cube roots. So negative numbers didn't have square roots on the list of real numbers. Negative numbers will have a real cube root every time. They'll also have 2 more roots in the complex number set, imaginary numbers, the square roots of negatives. We won't deal them in this course, but they do exist. You will see them in the future if you keep studying math. Now, let's look at some examples. The cube root of 8,640. Well, we find our prime factorization. It is 2 to the 6, 3 cubed, 5 to the 1. 6 and 3 are both multiples of 3. We can pull them out, divide them by 3. Gives us 2 squared, 3 to the 1, and then we still have the cube root of 5. That 5 stays behind. So the cube root of 8,640 is 12 cube root 5. We have turned an entire radical into a mixed radical. Now the cube root of 324x to the 7. Let's start breaking it down with our prime factorizations. 324 is 2 squared, 3 to the 4th. Now our cube root, 2 squared, doesn't have 3 2's, so those are going to both stay behind. 3 to the 4th, that's 3 cubed and another 3. So the 3 cubed can come out, and x to the 6th, or x to the 7th becomes x to the 6, x to the 1. So we're breaking down our 2's, our 3's, and our x's. Now those multiples of 3's, the 3 cubed and the x to the 6, we pull them out, divide the exponents by 3. It gives us 3 to the 1, x squared. That is what's outside. We still have a 2 cubed 3x on the inside. So the cube root we're looking for is 3x squared and the cube root of 12x. Example 3, the 4th root of 1,024. We can actually go past cube roots here. Yeah, the curricular outcome specifically says cube roots, but then read the details on their achievement indicators, and they do say that we should expect some students to go past cubed. So we'll do an example like that. Again, We do our prime factorization of 1024. That's 2 to the 10. The highest multiple of 4 that is less than or equal to 10 is 8. So that's 2 to the 8 times 2 squared. We pull out our 2 to the 8th, divide that 8 by 4. We get 2 squared times the 4th root of 2 squared. That's 4 times the 4th root of 4. Enough 4s for you? All right, exercises. Find the cube root of 32, a to the 7, b to the 4, c cubed. Pause now and take whatever time you need. Moving on, we have 2a squared bc and the cube root of 4ab. All right, find the cube root of 2,376, x to the 6th, y cubed, z to the 4th. Pause now. Take whatever time you need. All right, that is 6x squared yz and the cube root of 11z. Exercise 3. The 4th root of 354,375. Pause now and take the time you need. Our cube root here, our 4th root here is 15 times the 4th root of 7. All right, in summary, cube roots can be determined by removing all factors in a prime factorization whose exponents are multiples of 3 and then dividing those exponents by 3. In general, you could find the nth root of a number by pulling every set of n identical factors out of the radical and writing them as a single factor. So if you have any questions, any feedback, please leave them in the comments, and I will try to respond in a timely fashion. Again, this course is based on the 2016 version of Math 10C in the province of Alberta.